In this video, I'm going to explain the properties of the definite integral and then show you how to apply them to several examples. So let's assume that f and g are continuous functions. So the first property states that if I integrate f of x from a to a, I should get 0. Now that should make sense since my lower limit and my upper limit are the same value. That means I'm not going to have any area underneath, so therefore the area would be 0. Property number 2 states that if I integrate f of x from a to b, that is the same thing as the negative integral from b to a of the same function. So when I switch the limits of integration, I need to multiply the integral by -1. I guess you can think of that as having your upper and lower limit kind of moving backwards, and so it's going to be negative. The third property states that if I integrate a constant number from a to b, it's equal to the constant number times b minus a. Now, if you recall, if I draw y equals c, that would be a horizontal line. And then I want to integrate from b to a. So this is a, and this is b. Then I would have this area here inside. So what's happening is this would be the height times my width, and my width would be b minus a. The fourth property states that if I integrate a constant times a function from a to b, then I can actually remove that constant to the front of the integral, integrate the function first, and then times it by the constant number. Property 5 and 6 are related. If I integrate two separate functions, that is the same thing as integrating each function separately and then adding them together. And that's the same as if I was subtracting. So if I integrate the difference between two functions, then I can integrate each function separately and then subtract them after. The seventh property states that if I integrate a function from a to b, that's the same as integrating from a to c and then adding that from c to b, where c is a number between a and b. So let me show you how this works pictorially. So we have a, c, and b on this graph. So the first part says that if I integrate from a to c, that would be this area underneath the graph here. And then I'm going to integrate from c to b. That would be this other part of the graph over here, which I'm going to color in red. So if I add these two together, the green part that's shaded and the red part that's shaded, that is the same as integrating from a all the way to b. Now there are three more properties, and these are comparison properties. So the first one states that if the function is greater or equal to 0, and then I integrate that function from a to b, that value will still be greater or equal to 0. The ninth property states that if the function f is greater or equal to the function g for every x between a and b, then when I integrate each function from a to b as well, the integral of the f of x will still be greater or equal to the integral of g of x. And that should kind of make sense. And this is useful to get estimates for integrals. Now the last property states that if a function is between lowercase m and uppercase m for all the x's between a and b, then if I integrate that function f of x from a to b, that is going to still be in between the lowercase m times b minus a, and then the greater part, the greater value will be uppercase m times b minus a. So let's see how to use these properties. So I've given you some integrals first. We know that from the integral of f of x from -1 to 1 is 5. The integral of f of x from 1 to 4 is -2. Integral of g of x from -1 to 1 is 7. And then the integral of g of x from -1 to 5 is 3. So let's find these integrals. So this first one here, we want to integrate f of x from 4 to 1. Now this one closely resembles the second integral here, but I noticed that my upper and lower limits have been reversed. So what I'm going to do is I'm going to reverse these. So I'm going to have 1 to 4. But remember, when I do that, I need to use my second property, which states that I need to multiply by -1. So I'm going to put a negative in the front and then have f of x times dx. All right, so I already know that this portion here is the same as -2. So now I have negative 2, which means that this is going to be +2. All right, the next one here, I have to find the integral of f of x from -1 to +4. Now, I don't have anything like that, but I do have these two f of x's, and I have the integral from -1 to 1, and then from 1 to 4. So I'm going to rewrite this first as the as the integral of f of x dx from -1 to 1, and then plus the integral from 1 to 4 of f of x dx. So what I'm using is I'm using the seventh property. So from -1 to 1, I get the first portion, and then I'm going to continue from 1 to 4. And then that will give me the sum of from the lower limit to the upper limit. So I'm going to replace this with 5, and this is going to be -2. So then I get 3. All right, let's show you one more. So here we have the integral from -1 to 1 of -3 times g of x. So I want to show you how to apply property number 4. So we can move the -3 to the front. I'm going to rewrite this as -1 to 1, g of x dx. And then I can see that this part here is the same as this here, and that's 7. So I'm going to replace what I've circled here in green with 7. So then I get -21. And you can try the other ones on your own.